Hey guys, this looks like a fun one. We're trying to find the area of this yellow triangle. We're given two sides of x and a side of y, an angle of 60 degrees, an angle of 6 root y degrees, and an angle of log of x to the 30th power degrees. If you want to try this on your own, pause it right now because I'm going to solve it in 3, 2, 1. First, I'm realizing since these two sides are equal to x, that means this is an isosceles triangle. In isosceles triangles, the angles opposite the congruent sides are congruent to each other. Here's the notes right here. Since this side of length x has a 60 degrees opposite of it, this side of x would also have 60 degrees opposite of it. So let's change this whole thing into 60 degrees. And now we have a chance to solve for y. The sum of the interior angles of a triangle is equal to 180 degrees. So we have 60 plus 60 plus 6 root y is equal to 180. 60 plus 60 is equal to 120, and we can copy down everything else. Let's subtract 120 from both sides of the equation. On the left-hand side, we'll be left with 6 root y, and on the right-hand side, 180 minus 120 is 60. 6 root y is what this was right here, so we can change this into 60 degrees. I just realized the minute that we saw these two were 60, we immediately knew this was 60. But that's okay, we verified it here. Next, I want to solve for this side of y. So let's divide both sides by 6. On the left-hand side, this 6 and this 6 are going to cancel each other out, leaving us with the square root of y. And on the right-hand side, 60 divided by 6 is equal to 10. Next, to get the y all by itself, we can square both sides. On the left-hand side, the square root and the square are going to cancel each other out, leaving us with y. Does that make sense, y? And on the right-hand side, 10 squared is equal to 100. And now, in the place of this y, we can plug in 100. And then since all the angles are equal to 60 degrees, this is an equilateral triangle, meaning all the sides are equal to 100. Now we just got to find the area of this equilateral triangle with side lengths of 100. First, I got to verify that this checks out. So this log x of 30 needs to equal 60 degrees. If this doesn't check out, then the whole problem is impossible. So let's verify this just to make sure the answer isn't no solution. This logarithm is going to have a base of 10. And the reason for that is because we have 10 fingers. Next, we can use these notes to rewrite this log in exponential form. Anytime you have log base b of a equals c, it ends up being b to the power of c equals a. So this will be rewritten as 10 to the power of 60 equals x to the power of 30. We just rewrote this in exponential form. And then to solve for the x, we can take the 30th root of both sides. On the left-hand side, to do the 30th root of 10 to the 60th power, you're going to do 60 divided by 30 to get 2. So this will be 10 squared. And then on the right-hand side, same thing, the 30 divided by 30 is going to be 1. So we have x to the 1. 10 squared is equal to 100, and we now have the value for x. And that checks out. These x's are both equal to 100. So this is a valid triangle. And now we can find the area of the triangle. The area of a triangle is equal to 1/2 base times height. We can tell right here that this base is equal to 100, so we can plug that in. And then for the height, let's call it h. Let's draw this line perpendicular to the base, and let's label it h. In an equilateral triangle, this altitude is also an angle bisector, a perpendicular bisector, and a median. So this 60 up here is going to be split into 30 and 30, and the base of 100 is going to be split into 50 and 50. And in order to solve for the h, let's focus on this half of the triangle. There are two convenient ways we can do this. We can use these notes for 30, 60, 90 triangles, and realize that the side opposite of the 60 degrees is always square root of 3 times the shortest side. So this height is going to be equal to 50 root 3. And if you didn't know these notes for 30, 60, 90 triangles, you can also do a Pythagorean theorem. It'll be 50 squared plus h squared is equal to 100 squared. After you do all of this work, you also end up with h is equal to 50 root 3. And now we're ready to find the area. 1/2 times 100 times 50 is equal to 2,500. And this is still going to be multiplied by the square root of 3. And this is the answer to our question. Let's give it a label of square units and put a box around it. In this given yellow triangle, the area is equal to 2,500 root 3 square units. How exciting. And this is the problem I'm thinking about doing next. We're given a circle with 3 circles inside of it. This distance is equal to 1 meter, and it wants to know what is the radius of the bigger circle. This is going to be an interesting one. How exciting.